Hi, I'm going to be talking about the Bradford Assay. So one thing, the Bradford Protein Assay was developed by Marion M. Bradford in 1976. It's a quick and accurate stethoscopic analytical procedure used to measure the concentration of protein in a solution. It is subjective and dependent on the amino acids composition of the measured protein. It is a colorimetric protein assay, which is based on an absorbance shift of the dye Kussmaul's Brilliant Blue G250. Under acidic conditions, the red form of the dye is converted into its blue form, binding to the protein being assayed. If there is no protein to bind them, the solution will remain brown. As you can see here, the solution that have brown means that they don't have any proteins, but the ones that are really bright blue do, and the ones that are semi-blue, semi-brown have like a little bit in it. These pockets in the protein structure bind the non-covalent to the nonpolar region of the data via the first bond interaction, which position the positive amine groups in proximity with the negative charge of the dye. The bond is further strengthened by the second bond interaction between the two, the ionic interaction. The binding of the protein stabilizes the blue form of the Kussmaul's dye. Thus, the amount of the complex presented in the solution is a measure of the protein concentration and can be estimated by use of the absorbance reading. Unlike other protein assays, the Bradford protein assay is less susceptible to interference by various chemical compounds, such as sodium, potassium, or even carbohydrates like sucrose, that may be present in the protein samples. So one thing that we did use is a pipette. This is the one that we used because we were putting in 10 microliters. We also used a 96 well plate. After pipetting the 10 microliters of our dilation into triplicates on our well plates, we put 200 microliters of the Kussmaul solution and then put it inside the plate reader, like so. This is how it looks like. The plate reader, I lost my place. Then put it inside the plate reader where it read how much protein was in the solutions. We then took this data that we got, as you can see here, and we sent it to ourselves to find out what the unknowns were, because there were some unknowns, and you can see right here, I can show you the unknowns were these four. And I will show you that what we did with our data, how to change it into a graph, and yeah. Okay. So as you can see here, I have all the data. So this is the data here, A, B, C, D, E, F, G, H, and then 7, 8, 9, 10. Well, there's no 9. What happened to the 9? Okay, ignore that. So this is the data that we have here. And these are the protein concentrations that we originally had. Now, to find the unknowns, we first have to find the averages of these. Now, these right here are our unknowns, so they're not going to be in this data input. So I'm just going to control this and put this here. And then I'm going to delete this since we don't really need it. Just need this. So these are our unknowns, and the reason why there's only 2 instead of 3 is because the third row was very inaccurate and I think I messed up. But right here, these are actually pretty okay. So what we do now is that we do equals. That's not an equal, damn it. Okay, so what we do now is do equals, and then we go average. We click on average, and then we click these 3, and then you finish it and click enter, and it'll tell you the average of these 3 up here. And then if you just click here and go down, it will tell you the average of all of them. So if you click on them, you can see up here that it says average D3, F3, so D3, F3, so I messed up, D3, and then F3. So it'll tell you the average of each one, which is actually pretty cool. So then after you do that, you want to make a chart. So how you do that is that you underline this right here, and you drag it all the way over here. Now by doing that, you can make a table. So you go insert, stop. Oh, okay, never mind, I lied. So we're going to change this chart from a column chart to a scatter plot chart. And then you can see all of the dots that I made. And then after that, let's see, we go customize, and my computer is a little weird, so I have to double click on it again. Customize, and then we go series. We do tread line. Now you can do the labels like that. I mean, you can see right here I messed up a bit, but practice makes you better. You can change your color if you want, so I can change it to black, or I can change it to blue. Or I can change it blue or purple. Doesn't really matter. And nope. Okay, and then you go label, use equation, and show R2. So now that we have that, we have our equation, which is going to help us find our unknowns. So we exit out of this. Let's just put this over here to the side. It's gonna... Okay, let's just put this here to the side for now. So right here, I'm going to write OD average. And then right here, protein concentration. And since that's kind of in the way, I'm going to minimize this. Okay, there we go. So the same thing for the average is equals average. And then do this. And then if you just drag it down, you get your answer. But to find the protein concentration, it's going to be a bit different. We have to use this equation that was given to us. So what we would do is equals 1, 2, 3, 2. And the equation varied. Okay. So what we have to do is use the equation, but the equation varies depending on what you get here. So it would change for every OD average. So don't use the same equation for everyone. I made that mistake. So right here where you do equals 1, 2, 3, 2 times, and then if you look right here, this is E, oh, that's a 3, E 11, and then subtracted by, and then we'll put parentheses here because just in case the computer makes a mistake, and then subtracted by 381. So the reason why I would do subtraction is because, you know, there's a plus here, but if you get rid of the plus, it's still subtracted by it. And then you go enter, and that's the answer. And then if you go down, see, it does it for every single one. E12, E11. So this is the protein concentration, and then of course, if I move this down, and I take 1, 2, 3, 4, Control C, and then, you know, Control V. And there you go. You don't have to make a, come back. Okay. You don't have to make a chart for this one, but that's how you measure the unknowns for your proteins. Thank you for watching. I said thank you for watching.